Welcome to Study Loop.
Hello and welcome back. We are now into chapter 13, problem 34, and we're looking at which of the following in each pair is likely to be more soluble in water. So let's talk about water real fast before we look at anything else. Water has hydrogen bonding. It's also polar. And what do we know about polar? Any polar molecule will be soluble in a polar solvent. So let's look at our first set. A, we're looking at cyclohexane, C6H12. Just looking at that, is it polar? Nope, not at all. So this is a nonpolar molecule. The likelihood it's going to be soluble in a polar solvent, pretty low. So let's look at our one that we're comparing it with. We're looking at glucose. Even if we didn't know how to draw this out, there's a chance that these oxygens, there's 6 of them, could be attached to a hydrogen. So an OH group, is that capable of hydrogen bonding? Absolutely. So the chances that this is soluble are very high. So A, glucose, looks like our best contender on which one would be soluble in water. Let's go on to portion B, propionic acid. This is not a molecule that they'd want you to memorize. If you want to, feel free to go ahead, but let's write it out exactly as they have it here. We've got COOH. So again, we have an OH. So is this going to perform hydrogen bonding? Yes. Yes to H bonding. So this is a polar molecule. H bonding. And let's look at its cohort. So we're comparing it to sodium propionate. Again, another C, H3 to start with, CH2, and then we have COONA. So the only difference here I see between these two molecules is this group right here. Do we have any carbon or hydrogens bonded to oxygen? No. So this one has no hydrogen bonding. So which one is going to be able to have more interactions with water? The one with the OH group or the one without? If you said the propionic acid, then you would be correct. It absolutely has more interactions with water, therefore the chances that it'll dissolve in water are far higher. Let's look at C. We're going to do the same thing. So I'm going to write out HCl and then compare it to CH3, CH2, Cl. So let's see here. Can either of these hydrogen bond? No. There's no oxygen bonded to a hydrogen. There's no nitrogen bonded to a hydrogen, no fluorine bonded to a hydrogen. So there's no hydrogen bonding going on with either of these. So which one looks to be more polar? They both have chlorines. So both of them have a slightly negative pole to them. So this one's polar, and this one's polar. But this has a chain of carbons, and carbons are nonpolar. This one just has a hydrogen. So this one, when surrounded by water, can easily break into H's and Cl's, so hydrochloric acid. Whereas this ethylene chloride has more difficulty because anything bonded to carbon is going to have a stronger hold. So even though both are polar, this is an ionic bond, where this is a covalent bond. And that's the difference. The ability to break a covalent bond is far harder than ionic in water, because water is going to interact with both the positive and negative sides of this molecule, whereas this one, there's more in the way to be able to react. So if you said hydrochloric acid, you'd be absolutely correct. Good job. All right, see if you can work the next problem on your own.